first question is consider a language L over A comma B in which each string has A as substring. Here we need to design non-deterministic finite automata which recognizes L and convert it into DFA. Then we need to write tuple form, transition table and transition diagram. So first, take this part. So consider this language which accepts or which contain ABA as substring. So this is the NFA. So here ABA is a substring. And before this, you can have any number of A's and B's. After this, any number of A's and B's. So language can be written like this. L equal to minimum string is ABA. ABA. You can have B followed by B. So ABA is a substring. Or string may even start with B also. And end with any number of A's and B's and so on. So this is the NFA. Now, tuple form for this is, so first we already know that NFA is a collection of phi tuple Q sigma delta Q naught F. So Q is set of states. So here in this diagram, we have total 5 states from Q0 to Q3. Sigma is set of input symbols. Input symbols are A and B. Delta is a transition function. So delta of Q0 on input symbol A, we have self loop. So on input symbol A, it is staying in same state Q0 as well as another path is from Q0 to Q1. So this is Q0 Q1. Then delta of Q0 on B. So Q0 on B is again Q0. Q1 on B, it is Q2. Q1 on A, there is no path on A. So this is empty, or you can write phi. Q2 on A, it stays in, it moves to Q3. Q2 on B, there is no path. So this is phi or empty. Q3 on A stays in same loop, same state Q3, as well as Q3 on B also same state Q3. And then Q0 is the initial state and F is the final state. Final state is Q3. Now we need to draw a transition table. So for this NFA, this is a transition table. So Q0 on input symbol A, it is staying in Q0 as well as going to Q1. Q0 on input symbol B is staying in same state Q0. So just now we saw these transitions. You need to write them as it is. Then coming to the conversion. So NFA to DFA should be done here. So how to do this means, first take this first row as it is from NFA table. After this, we need to take this Q0 on input symbol A goes to Q0 Q1. So you need to consider that as a new state and find out transitions for that. So Q0 Q1 on input symbol A, you can see this. Q0 Q1 on input symbol A can be written as Q0 on input symbol A union delta of Q1 on input symbol A. So Q0 on input symbol A is Q0 Q1. So write Q0 Q1 union Q1 on input symbol A. It is phi. So final result is Q0 Q1. So Q0 on input symbol A is Q0 Q1. So here we wrote it directly. Whereas Q0 Q1 on B. So in place of A, we need to place B. Q0 on input symbol B is Q0. So remove this. And Q0 on input symbol, Q1 on input symbol B is Q2. So Q0 union Q2. So that is Q0 Q2. So Q0 Q1 on input symbol B is Q0 Q2. Now check if you got any new states. So we completed Q0 as well as Q0 Q1. Now we got one new state Q0 Q2. So take that and find out transitions on Q0 Q2. So we'll use the same approach for that. So we got Q0 Q1 Q2. So write it here. Q0 Q2 on input symbol B is Q0 only. Now check if you got any new states other than these three. Yes, we got Q0 Q1 Q2. So take that as a next state and write this one. So here you will get Q0 Q1 Q2, Q0 Q2 Q3. So this Q0 Q2 Q3 is a next state or a new one. So take that. Again, find out transitions on this. We got one more new state, Q0, Q3. So perform or identify transitions for that. So this is the DFA transition table. So here what we did, initially we considered this ABA as substring and constructed NFA for that. And this is a tuple form and transition table for NFA. Then we are writing tuple form for DFA also. And we are going to find transition functions for this DFA also with the help of NFA transition table. So after conversion, this is the final transition table for DFA. You can see the transition diagram also. So this should be drawn based on this diagram. So here Q0 on input symbol A, Q0 Q1. So Q0 on input symbol A, Q0 Q1. Q0 on input symbol B is Q0. So here we need to take it as self loop. Then Q0 Q1 on input symbol A, it is staying in same state. Q0 Q1 on input symbol B, it moves to Q0 Q2. So like that, with the help of this DFA transition table, we need to construct this finite automata or this transition diagram. Next question is, consider the epsilon NFA. So this is epsilon NFA and we need to compute epsilon closure of each state, then convert epsilon NFA to NFA. So this is the epsilon closure. First, you need to find that epsilon closure of Q0 is, we need to check the outgoing epsilon paths from Q0 as well as consider that state itself. So for epsilon closure of Q0, it is Q0 itself as well as there is one epsilon path from Q0 to Q2. So that is Q2. Then epsilon closure of Q1 is that Q1 itself and there is an epsilon path from Q1 to Q2. So Q2. Then epsilon closure of Q2 is Q2 itself. There is no epsilon path from Q2 to any other state. So first part was done. So we found epsilon closure for each state. Then we need to convert epsilon NFA to NFA. So this is the epsilon NFA. So process first we need to take delta dash of Q0 on input symbol 0, which can be written as epsilon closure of delta of epsilon closure comma 0. So epsilon closure of delta of epsilon closure of Q0 on 0 is, you can see it is Q0 Q2. So this is epsilon closure of Q0 on input symbol 0. It is Q0 Q2 comma 0. This can be written as delta of Q0 on 0 union delta of Q2 on 0. So delta of Q0 on 0. So Q0 on 0 is Q0 as well as, sorry. So delta of Q0 on 0 is Q0 union Delta of Q2 on 0. Q2 on 0 is Q2. So we'll get Q0 Q2. Then delta dash of Q0 on input symbol 1 is epsilon closure of delta of epsilon closure of Q0 comma input symbol 1. So epsilon closure of Q0 is Q0 Q2. Q0 Q2 on input symbol 1. So here in place of 0, we need to place 1. Q0 on input symbol 1 is Q0 as well as Q1. So Q0 comma Q1. Then Q2 on input symbol 1 is Q2. So if you take union, you will get Q0, Q1 and Q2. Then delta of Q1 on input symbol 0, which is epsilon closure of delta of epsilon closure of Q1 comma 0. Epsilon closure of Q1 is Q1, Q2. So replace that and use the same method in order to find out delta of Q1, Q2 on input symbol 0. So we'll get epsilon closure of Q2. Epsilon closure of Q2 is Q2. Then delta dash of Q1 comma 1. So we need to do on both input symbols 0 and 1 for every state. So epsilon closure of delta of epsilon closure of Q1 comma 1. So epsilon closure of Q1 can be written as Q1 Q2. And then delta of Q1 on input symbol 1 is, there is no path. So this is 5. And delta of Q2 on input symbol 1. Q2 on input symbol 1, it stays in same state Q2. So epsilon closure of Q2 is Q2. Then delta dash of Q2 on 0. So here epsilon closure of Q2 is Q2. Then find out delta of Q2 on 0. Q2 on input symbol 0 is Q2. So epsilon closure of Q2 is Q2. Then delta dash of Q2 on input symbol 1. So this is epsilon closure of Q2, which is Q2. Then delta of Q2 on input symbol 1, it stays in same state Q2. So epsilon closure of Q2 is Q2. So here you can see this transition table also. Delta of Q0 on input symbol 0 is Q0 Q2. Q0 on input symbol 1, Q0 Q1 Q2. Then Q1 on input symbol 0, Q2. Q1 on input symbol 1, Q2. Q2 on input symbol 0 as well as input symbol 1 are Q2. You can draw the transition diagram with the help of this transition table.